Hi everyone. Before we start, just in case if you are looking out for preparation for top tech companies and FAANG based interviews, check out Renaissance, which is a comprehensive interview prep program where you get to learn data structures, algorithms, CS fundamentals, low level design and high level design in a great detail. Cool, so let me set context for today. We are going to learn about another most important thing which we have to do in computer science. It's an algorithm. It has got so many different techniques inside it. But yeah, in simple words, we call it sorting. Okay, so why do we do sorting? Why do you sort your data? Anyone who would like to talk about it? Just throw your opinions. Why would you like to sort some data? To make searching easier, to easily analyze, to store elements in a particular way, in an order. Okay, have you already learned about searching algorithms? Yes, we learned about searching algorithms and we realized that if the data is ordered or if it is sorted, it becomes easy to search through it. That is one of the primary reasons why we want to sort the data, right? Now, there are different data structures that store the data in sorted form. Different data structures like that. For example, you can imagine how it works and how it works inside the computer memory. So let's say you are trying to search something in database. So let's say there is a database which contains the names of all the persons in the world. Okay, so now if you have that stored in your computer memory, one of the most efficient ways, people say that there is a memory block and this memory block points to another memory block which only contains those names that start from A to D. So if your name starts from A, B, C or D, then your name will be found in this memory block. Similarly, if your name starts from, let's say, E to K, then the entry will be found in this memory block, so on and on and on. This way, what happens? Let's say you have to search for a person whose name is Elgar. So you have to search for Elgar, then you will not go to this memory block and waste your time. You will immediately come to this memory block because you know that all the names that start from E to K is present here. So there are different data structures like this. There is something called as binary search tree. There is something called as binary index tree. Inherently, the idea behind them is to store the data in some order, to store them in sorted form, so that it becomes very easy to retrieve them, so that it becomes very easy to search them. We'll talk about these data structures in the time to come, but I just wanted to set a context that the major reason behind sorting the data is to make search easy. Okay, cool. So let's talk about it. You want to sort some data. What is the definition of sorting? If I, let's say, give you an array which contains integers like -5, 1, -6, 0, 3, 8. I'll tell you a vague statement. The statement will be sort this thing for me. Will you be able to sort or will you ask for more information? Yeah, you should ask for more information. So you will ask that, okay, you want me to sort it, but in which order you want me to sort it? So let's say I tell you that, okay, sort it in ascending order. So if you have to sort it in ascending order, the smallest element is -6, then is -5, and then is 0, 1, 3, 8. So that's ascending order. If I ask you to sort in descending order, how will it look like? In descending order, the largest element is 8, followed by 3, followed by 1, 0, -5, -6. That's your descending order. Now there can be variety of different orders. So let's say I come up with a new order, and that is I want to sort on the basis of magnitude, which is absolute value. I want to sort on the basis of absolute value. So whichever element has smallest magnitude or smallest absolute value should come first, and whichever element has largest absolute value should come later. So if I ask you to sort on this basis, what will be the result? Print the result on the chat box. 0, 1, 3, minus 5, minus 6, 8. That is what Ajay has written. Others? You agree to that? So which element has the smallest absolute value here? That is 0. Next 1. Next 3. Next minus 5. Next minus 6, and then 8. So now if you just look at their absolute values, the absolute values are 0, 1, 3, 5, 6, and 8, and they are sorted in the ascending order of absolute values. Okay. Somebody can come up with some other kind of ordering. Somebody can say that, okay, sort the data in such a way that all the events come first and then odds appear. So I want to sort the data in such a way that first all the even elements appear and then all the odd elements appear. So what will be the result? What will be the result if you try to sort the data on this basis? Or do you feel information is still missing? There can be multiple results. Do you feel like that? Yes, one of you has a very good question. That if you want to ensure that all the events come first, what are the events? 0, minus 6, 8. These are the events. So you want 0, minus 6, and 8 to come first, and then you want minus 5, 1, and 3 to come later. But I mean, what should be order of even elements among themselves? I mean, do you want minus 6, 0, 8, or do you want 0, 8, minus 6, or do you want something else? So that also needs to be specified. So one would say that, okay, amongst events, the elements should be sorted in ascending order, and amongst odds, the elements should be sorted in descending order. So now what will be the result? Just print it. So if you want amongst events, everything should be sorted in ascending order, you will get minus 6, 0, 8. And amongst odds, if you want to be sorted in descending order, the largest odd is 3, and then is 1, and then is minus 5. Okay, the entire point of this exercise is that I want you guys to realize that there can be different sorted forms based on the input, based on how we want to sort the data. So we need to understand that now onwards, we will not just sort the data in ascending or descending. We will sort in some custom order, and that custom order can be something that question specifies. Is it making sense to everyone? Yes or no? So how many of you have learned sorting algorithms in your, I mean, first or second semester, you would have learned how to sort data while you would be learning C or C++. I don't know which language you learn, but you must have learned how to sort it, right? Okay. So which algorithms have you learned for sorting the data? Bubble sort. Okay. Anything else? Okay. Selection sort, quick sort, everything. Can you use bubble sort to sort this data according to this order? Can you do that? Okay, how many of you feel that you can use bubble sort to sort the data in ascending or descending, but you might not be able to sort in this custom order? If you feel like that, just type in yes. If you feel you will not be able to sort based on the desired order, just type in yes. We will learn how to do that, because you cannot live without learning how to do that, because you will not just be sorting the data in ascending and descending. It will be sorted on different custom rules that will be there. I'll talk about bubble sort, don't worry. If you don't know bubble sort, don't need to worry. I'll come to that. Okay, cool. So now that we understand that there can be different orderings, let us move on. I just want you to remember this fact that there can be different orderings. This is going to set the context for today. Okay, so if let's say I want to talk about sorting a data in ascending order, what is the meaning of sorting data in ascending order? It means that if I have some elements like A1, A2, A3, A4 till AN, then I want to generate a permutation of it, because sorted form is just a jumbled up form, which is just a permutation. So I want to create a permutation of it such that if the first element in the permutation is A1 dash, then A1 dash should be smaller than or equals to A2 dash, should be smaller than equals to A3 dash, so on and on. It should be true till the end. So this thing is a sorted permutation. Okay. Now, what is the easiest way in which we can sort a data? You have been given elements like 3, 1, 2, and I want you to sort it. The easiest way is I can just go ahead and generate all the permutations. How many permutations will it have? If there are n elements in an array, how many different permutations will be there? Let's say all the n elements are distinct. N factorial different permutations, right? Because you can say that, hey, for the first element, there are n choices, for the second element, n minus 1 choices. So what you can do is you can generate all the permutations, and out of all the permutations you generated, just pick that which follows this rule. So if I know how to generate all the permutations, I can generate them and pick the one that follows this rule. This is the easiest way to solve this question. Does that sound sensible? Yes or no? Okay. Cool. Now, this is definitely not a good approach, because if you generate all the permutations, it will take you n factorial time, and n factorial is a huge quantity. Remember, if just your n is 100, 100 factorial will be big. That's not a scalable approach. Okay. Cool. Now tell me one thing. Can it happen that there is an array for which multiple permutations represent the sorted form? Multiple permutations represent the sorted form. Is that possible? Like here, there is only one permutation that represents the sorted form, 1, 2, 3. But can I have an array where multiple permutations represent the sorted form? What are you saying? When the elements are duplicate. Now think, if you have duplicate elements, then can it happen? So let's say we have an array containing 2, 1, 2, 3. Okay. Now just to show difference between this and that, I'm going to say this is my first 2 and this is my second 2, right? So if I want a sorted permutation, I can say it is going to be 1, 2, 2, 3, and I can bring the first 2 here, second 2 here, or I could have brought the second 2 here, first 2 later. Both of them are sorted permutations. Can I say that? Yes or no? Right? Both of them are sorted permutations. But what is the key difference in them? There is a key difference. The key difference is, in this sorted permutation, the first 2 came first and the second 2 came second. But in this permutation, the first 2 came later and second 2 came first. So do you see one thing, that in this permutation, the relative order of elements have been preserved. The relative order of equal elements have been preserved, which means if there are 7 instances of 2, then the first 2 comes first, second 2 comes after that, third 2 comes after that, and seventh 2 comes at the last. But here that preservation is not done. Do you note this thing? Yes or no? So this kind of sorting, this kind of sorted data is called as stable. This is stable sorting, and this is unstable sorting. So what is the meaning of stable? Stable simply means that the equal elements, when they appear, their order should be preserved. That is about stable. And unstable means if the order is not preserved, then that's unstable. Is everyone clear with the concept of stability? It's a very important concept pertaining to sorting algorithms. So when will these cases arise? I'm going to tell it again for one last time. When will this case arise that there are multiple sorted permutations? It will arise if there are duplicates. If there are duplicates, let's say this is your first 2, this is your second 2. So in your sorted form, would you want to bring the first 2 and then the second 2? Or would you want to bring the second 2 or the first 2? This is determined by whether you want stable sorting or unstable sorting. Stable sorting means that out of all the equal elements, the first occurrence should occur first and last occurrence should occur last. That's stable. Everything else is unstable. Now there should be a good question that should be going inside your head, that, hey, why is it important? How many of you feel like that? How many of you feel that why we are even talking about stability? Does it have any use? That's a good question. Let's talk about it. See, if you have a data which only contains integers, then you will not be able to figure out that why do we need stability at all? Like, who cares whether the first two comes first or the second two comes later? But in the real world, the data that you have is not just an integer, it's an object. It's something of it's a structure which can contain so many things inside it. So let's take an example. Let's say we have got start and end times of some movie shows. Okay. So the first movie, it starts at 2 p.m. ends at 3 p.m. The second movie from 1 to 4, then 2 to 5, and then 3 to 9. What I want to do is I want to sort on basis of start time. I want to sort these movies on the basis of start time. So tell me, what will you get? How many of you feel there can be multiple results? Can there be multiple results? If I want to sort on the basis of starting time, the movie with the smallest starting time is that, so you'll get 1-4. And the movie with the largest starting time is that, so you'll get 3-9 at the end. But you will be confused whether this should come first or that should come first. So now the question says, sort on the basis of start time in a stable manner. In a stable manner. So what does it mean? That if there are multiple data, multiple movies that have the same starting time, then the one which came earlier should come first. Now, does it matter? It matters, because this movie is different than that movie. It ends at a different time, and that ends at a different time. So when you have data that is complex, that has so many fields inside it, and you want to sort on the basis of a particular field, stability would matter a lot. We'll see the data to be different. Does that make sense? How many of you realize why stability? Why is that important? Just type in yes or no. Okay, we'll talk about all these things, that how to sort in a stable manner, how to ensure stability and all. We'll get into those details later. But before that, we'll quickly talk about some very, very simple sorting algorithms.